It began when the gases erupted. From deep inside 3I Atlas, jets of cold light burst outwards, silent, symmetrical, and completely wrong for a comet. They weren't the usual streams of vaporized ice. These plumes were dense and metallic, glowing in a blue so pure that even the instruments struggled to categorize it. Every few minutes, the emissions repeated like a heartbeat, synchronized with nothing known in physics. The silence of space is never truly silent. It hums with background radiation and the quiet rhythm of distant worlds. But that night, on October 2nd, 3I Atlas changed that rhythm. Telescopes across orbit began to record gases unlike anything seen before. Cold, ionized, and structured. They formed a luminous haze around the comet, a halo of moving geometry that defied all models of natural sublimation. Before we begin, remember to subscribe if you're new here, and tell me in the comments the exact time where you're watching from right now. Now, let's return to the moment those gases first appeared the night the data turned blue. It began with silence. Not the kind of silence that fills empty rooms, but the kind that fills the universe. A silence woven with background radiation, the quiet hum of particles in motion. On the night of October 2nd, that silence broke. The trace gas orbiter, orbiting Mars, recorded a sequence of signals that would rewrite everything scientists thought they understood about 3I Atlas. At precisely 2:14 UTC, the orbiter's onboard spectrometer detected a flicker of blue. Not a reflection, not solar interference, but a luminous emission that pulsed in a way no natural gas ever had. The frequency matched no known molecule in the cosmic database. Its wavelength sat at 441 nanometers, normally associated with ionized neon, but the surrounding temperature was far too low for ionization to occur. The data appeared to contradict itself, as though the instrument had recorded something that wasn't supposed to exist. When the data team at Darmstadt replayed the raw feed, the blue emission appeared again, this time stronger. The surrounding pixels dimmed slightly, as though the comet's light was absorbing rather than radiating energy. Instrument error, one analyst suggested. But the readings didn't vanish, they repeated. 6 times in total, separated by identical intervals of 27 minutes. It was not noise, it was rhythm. The trace gas orbiter's instruments were built to detect methane and oxygen signatures in the Martian atmosphere. They were not designed to read deep space spectral patterns. Yet that night, the sensors turned outward, toward 3I Atlas, as part of a calibration test. And that's when the anomaly appeared. The team at the European Space Operations Centre initially believed solar wind or cosmic rays had caused false reflections. But when they filtered out the background interference, the pulse remained clean, deliberate, and eerily symmetrical. Each burst of blue carried an internal microstructure. Within the main wavelength band were smaller oscillations, like whispers encoded inside light itself. Advanced Fourier analysis showed that those fluctuations followed a precise ratio, 1.618 to 1, the Fibonacci constant. Nature creates patterns, but rarely with that level of mathematical perfection. Hours later, 2 other instruments confirmed similar readings. The Mars Reconnaissance Orbiter's visual spectrometer caught the faint afterglow on the outer coma of 3I Atlas, while the Bepi-Colombo probe detected a corresponding electromagnetic resonance, a soft, repeating hum in the VLF band. Each time the blue pulse appeared, the comet's internal magnetic field wavered ever so slightly, as if reacting to its own heartbeat. By morning, word had spread quietly among the European Space Agency's research teams. Some called it the Blue Event. Others refused to classify it at all. There was hesitation to release the data publicly, not out of secrecy, but confusion. How could a cold interstellar object emit coherent blue light without a source of excitation? When the analysis reached the Astrobiology Center in Madrid, a curious suggestion emerged. Perhaps what the instruments were detecting wasn't light in the traditional sense. Instead, it could be a form of low-energy plasma-ionized gas, so stable that it maintained structure at temperatures near absolute zero. If true, that would imply an environment within 3I Atlas, capable of sustaining ordered plasma flows without heat, something unheard of in astrophysics. NASA's Deep Space Network later reviewed its own data from that same window. Antennas in Canberra registered a minor deviation in background noise, a faint, rhythmic dip every 27 minutes. perfectly synchronized with the blue flashes. Statistically, that coincidence bordered on impossible. When the reports were compiled, one detail stood out above all others. Each emission aligned with the comet's rotation, but offset by 11 degrees, as if something inside was pulsing slightly out of sync with its own spin. A natural explanation proved elusive. Sublimation of surface ice could not account for the periodicity, nor could reflected sunlight, since the object was in Mars's shadow for part of the observation. As the data continued to pour in, one sentence began appearing in the internal memos shared between ESA, NASA, and JAXA analysts. The object is not cooling, it's communicating thermally. Whether that statement was meant literally or metaphorically remains unclear. But from that night onward, 3i Atlas was no longer described as a passive traveller through the solar system. It was described as active. Something about it seemed to know how to balance light and cold, motion and stillness. A choreography written in blue. No one knows what truly happened that night above Mars, but the data remains archived under a new label. Anomalous luminescence. Category 3. For scientists, it was a reminder that even in the stillness of space, colour can sometimes speak louder than sound. And on that night, the silence of the universe turned blue. When the first readings came in from the James Webb Space Telescope, the team assumed it was a calibration echo, a simple misfire in the spectral pipeline, but the data wouldn't clear. It kept coming back, a faint, repeating pattern that didn't match any known element or compound. Something inside the gaseous tail of 3i Atlas was emitting in chemical frequencies that didn't belong anywhere on the periodic table. The discovery began in the mid-infrared band, around 4.3 microns, a range where carbon dioxide and methane usually dominate comet signatures. Yet these readings were neither. The molecular lines were clean, too symmetrical, and carried traces of vibrational energy inconsistent with organic gases. In plain terms, it wasn't carbon, oxygen, or nitrogen. It was something that shouldn't exist. When researchers overlaid the emission spectrum with archived data from Oumuamua and Borisov, the first two confirmed interstellar visitors, they noticed how ordinary those comets looked in comparison. Natural gases scatter. Their spectra appear chaotic, uneven, noisy, but the gas escaping from 3i Atlas formed perfect intervals, a pattern with harmonic spacing, the kind seen only in controlled chemical reactions. For several nights, Webb's near-spec instrument tracked the emission lines as the comet rotated. What they found stunned everyone in the control room. The intensity of the signal did not vary with sunlight. Whether 3i Atlas was facing the sun or drifting into Mars's shadow, the emissions stayed stable, as if powered by an internal process. ESA's Mars Express orbiter confirmed the reading independently. Its high-resolution spectrometer detected matching frequencies in the ultraviolet range. Two separate instruments, on different sides of the solar system, were watching the same invisible reaction unfold in real time. As the data poured in, analysts began labeling the files unregistered compounds, shorthand for chemical fingerprints, with no known match. These weren't random signals. They repeated every 41 minutes, showing molecular peaks near the transition states of nickel, cobalt, and something between the two. The ratios didn't make sense. There is no natural element between nickel and cobalt. On Earth, those two metals are atomic neighbours, inseparable in formation. But here, there was something sitting in between an intermediate frequency. A ghost element that vibrated where the periodic table says there should be nothing. In a late-night session at the European Space Research Centre, a chemical physicist proposed that these frequencies could represent metastable isotopes, temporary atomic structures that form under intense pressure and collapse within seconds. But these signals had lasted for hours, steady and repeating. To persist that long, something must have been regulating them. NASA's Deep Space Network then detected weak electromagnetic fluctuations in sync with the emissions. The waves carried a fine modulation pattern, almost like a pulse. When converted into audio, the data produced a low, steady hum that rose and fell every 40 seconds, mechanical, deliberate, and unnervingly constant. On the fifth day of analysis, researchers noticed something even more disturbing. Each chemical peak aligned perfectly with 3i Atlas's rotational period, but the phase angle was offset delayed by 0.3 seconds every cycle. The gases weren't reacting to rotation, they were reacting with it. The emission pattern appeared to anticipate motion before it occurred, as if it were being synchronized from inside the object. To test the hypothesis, the team ran simulations using standard cometary models, solar heating, volatile release, magnetic turbulence. None fit. Even exotic models involving trapped hydrogen ice failed to reproduce the stability. The only framework that matched was something rarely discussed outside deep space propulsion research: reactive ion acceleration, a process where charged gases are vented intentionally to generate precise control. Of course, that couldn't be the case. 3I Atlas was not a machine. At least, that's what the data teams repeated to themselves. Still, the readings remained structured, stable, engineered in behavior, if not in origin. By the end of the week, ESA officially labeled the finding as a non-classified volatile anomaly. The report concluded with one unsettling line: the emission ratios suggest chemical design or evolution under unknown thermodynamic constraints. In the quiet corridors of mission control, that sentence hung heavy. For the first time, the question was no longer what 3I Atlas is made of, but why it releases what it does, and who or what is controlling the reaction. Whatever these gases are, they refuse to behave like nature's work. They act like instructions written into matter, a message in chemistry, waiting to be read. At first, scientists thought it was interference. The instruments aboard Mars Express began returning strange distortions, not in the light spectrum this time, but in the magnetic field surrounding 3I Atlas. For days, the data appeared chaotic, until the software that filtered solar wind noise was disabled. What emerged from the raw stream was something organized, a magnetic structure wrapping around the comet like an invisible shell. Normally, comets are magnetically quiet. They don't generate fields of their own. They borrow the sun's magnetism, deflecting charged particles as they pass. But this was different. The readings indicated polarity north and south rotating in sync with 3I Atlas's spin, yet independent of the solar field. The field lines were closed, self-sustaining, and strong enough to redirect plasma from Mars's ionosphere. A comet cannot do that. The Trace Gas Orbiter detected the same anomaly minutes later. Instruments designed to study methane resonance on Mars suddenly recorded surges of magnetic flux. At first, technicians blamed cosmic radiation, but when the pulse repeated every 11 hours, matching 3I Atlas's rotation, the coincidence became impossible to ignore. Spectrographic visualizations showed that the gas escaping from the comet was aligning itself along these magnetic lines. It wasn't just drifting, it was organizing. The pattern resembled the magnetic corridors of Earth's auroras, except here, there was no planetary core, no iron dynamo, no molten rotation. The only possible explanation was induction, but induction requires current. Something inside 3I Atlas was generating power. The magnetic field expanded steadily over the next 48 hours. Its radius grew from 60,000 to nearly 110,000 kilometers, forming what ESA engineers nicknamed the Veil. Mars Reconnaissance Orbiter reported that the solar wind behind the comet bent sharply, creating a clean bow shock, something usually seen only in magnetized planets like Earth or Jupiter. What made the Veil extraordinary was its stability. Magnetic fields produced by solar interactions fluctuate violently. They twist, collapse, and rebuild in milliseconds. But this one held firm. The lines were smooth and coherent, as if following instructions. Every model predicted chaos, but the data showed precision. A research group in Kyoto compared the field geometry to a toroidal generator, a design used in fusion reactors to confine plasma. The similarity was unnerving. The gas wasn't just following magnetism, it was contributing to it. Charged particles were cycling along paths that looked engineered, maintaining balance between attraction and repulsion. NASA's Parker Solar Probe, then on the outer edge of its orbit, detected ripples in the heliospheric current sheet that corresponded exactly with the Veil's emergence. For a brief moment, the entire magnetic balance between Mars and the Sun shifted, a measurable change caused by something no larger than a small moon. In private channels, ESA scientists debated what could cause a self-contained magnetic system in an interstellar comet. One hypothesis suggested a superconductive core, a material capable of carrying current with zero resistance. Another proposed a plasma dynamo triggered by metallic gas, but both required temperatures and structures beyond anything seen in a natural body. As the veil expanded, its surface began to interact with sunlight. Photons refracted along its edges, forming faint halos of green and violet light, like a ghostly aurora, drifting through deep space. Amateur astronomers caught glimpses of it through long-exposure imaging, mistaking it for a tail of ionized gas. But under spectral analysis, it wasn't a tail at all. It was containment. The breakthrough came when a team at ESA cross-referenced the veil's pulse frequency with 3 I-Atlas's known rotation speed. They discovered that every time the field completed one magnetic cycle, a minute's surge in luminosity followed from the nucleus as if the comet was charging and discharging energy. By the end of the week, the consensus was divided. Some called it a magnetic resonance phenomenon, a natural product of exotic materials colliding with solar radiation. Others whispered about something else, an adaptive process, one that could regulate its own magnetic shield in response to the environment. The official report ended with a line that has since become infamous in scientific circles. 3. Atlas exhibits a magnetic field of organized coherence, inconsistent with any known non-technological process. No one knows what that means yet, but one fact remains. For the first time in recorded history, a comet has surrounded itself with a magnetic veil, a silent armor that bends light, redirects plasma, and refuses to obey the universe's rules. Whether it's a natural wonder or something far older, the veil now marks 3 I-Atlas as more than just a traveler. It's something that protects itself. In the physics of comets, heat is everything. When sunlight strikes a comet's frozen surface, it ignites the familiar process of sublimation. Ice turns to vapor, gas erupts outward, and the coma glows in response. Every model, from Newton to Rosetta, depends on that single assumption. Heat equals motion. But in late October, as 3 I-Atlas approached the orbit of Mars, that rule quietly broke. For reasons no one could immediately explain, the thermal data went in reverse. Instead of heating as it released gas, 3 I-Atlas grew colder. At first, the anomaly looked like an instrument drift, a minor calibration error in the ExoMars trace gas orbiter. But the drop was consistent across multiple detectors: optical, infrared, and microwave. Within hours, the comet's recorded temperature fell by nearly 8 degrees Kelvin, even as its gas output increased. The first to notice was a data analyst named Ryoko Mendez working the night shift in Darmstadt. She was recalibrating the orbiter's spectrometer when she saw that the thermal graph dipped every time the comet's gases spiked. It looked like it was feeding on its own heat, she later wrote in her field log. As if the energy didn't escape, it inverted. The readings were rechecked using Mars Express and the James Webb Space Telescope. Both confirmed the impossible. 3 I-Atlas was releasing massive amounts of gas, but none of it carried the expected thermal signature. Normally, sublimating ice leaves behind trails of water vapor, dust, and reflected solar heat. But here, the gases were dark and cold, absorbing radiation instead of emitting it. When NASA's Goddard Center modeled the energy balance, they found a gap. Almost 20% of the expected heat simply vanished. Not radiated, not stored, but missing. The numbers refused to close. One hypothesis proposed that the gas consisted of high-density molecules capable of endothermic bonding reactions that consume heat as they occur. That would mean the comet was somehow regulating temperature internally, turning energy into structure. James Webb's mid-infrared spectrometer caught something stranger. Faint emissions in the 4.2 band, the same region used to track carbon dioxide. But these emissions were inverted. Instead of radiating outward, the light curve bent inward, showing a form of negative brightness. In lay terms, the gas wasn't shining. It was swallowing light. In laboratory conditions, such behavior has only been seen in quantum materials known as photonic absorbers, engineered surfaces that trap electromagnetic energy with perfect efficiency. The idea that a comet could exhibit a similar effect was beyond reason. Yet that's exactly what the data implied. ESA scientists tested for known natural causes: shadowing, dust occlusion, albedo shifts. None fit. The pattern repeated every 11 hours, following the same rhythm as 3 I-Atlas's magnetic veil. Wherever the magnetic field strengthened, temperature collapsed. The two phenomena were intertwined. as if the comet was using magnetism to drain heat from itself. A theory began circulating internally unofficial, never published, that 3I Atlas might contain superconductive materials capable of channeling energy across its core without resistance. In such a state, even small changes in radiation could be redistributed almost instantly, explaining the near-perfect thermal control. But that would require a level of organization far beyond any natural rock or ice body. On October 22nd, a sudden spike in solar radiation provided the ultimate test. A mild coronal mass ejection struck the comet's trajectory head-on. Every other nearby satellite registered increased heat signatures, yet 3I Atlas responded with silence. Its temperature didn't rise. It fell sharply. Within minutes, the surrounding plasma cooled so drastically that ExoMars lost its lock on the thermal signal entirely. The comet vanished from infrared sensors, as if it had switched itself off. When visibility returned hours later, its surface composition appeared unchanged, but its coma had grown wider, more diffuse, the gases spreading outward like mist from a frozen lung. The event sent ripples through every observatory tracking it. "We're watching a body that refuses thermodynamics," one researcher said on record. "Either it's the coldest active object we've ever found, or it's using heat in ways we don't yet understand." The working term soon became thermal inversion phenomenon. Publicly, it was described as an unexplained cooling phase. Privately, it was treated as a controlled response, something deliberate. The veil and the temperature drop had synchronized perfectly, suggesting that the comet could regulate both light and heat at once. By the end of that week, the consensus had changed. 3I Atlas was no longer just sublimating. It was behaving like a system, absorbing, redirecting, and preserving energy in defiance of every physical expectation. And so the night it should have burned brightest became the night it dimmed instead. A comet that should have boiled in sunlight grew colder in its core, as though protecting something deep within. The heat didn't disappear. It obeyed a new rule, one written by 3I Atlas itself. The first sign that something had changed didn't come from the sky. It came from the servers. At 3:42 UTC, researchers monitoring 3I Atlas from the European Space Agency's Open Archive noticed a sudden update. The public data log, which had been filling steadily with infrared readings and spectrometer calibrations, froze. When access returned 2 hours later, one of the primary datasets, the October 22nd thermal scan, was gone. In its place appeared a single placeholder file labeled "Awaiting Calibration Review." At first, no one questioned it. Large missions often pause uploads during internal reviews, but when independent observatories in Japan and Chile tried to retrieve the raw data through mirrored feeds, they too received blank responses. Every file linked to the comet's thermal activity had been replaced simultaneously across ESA's servers. Someone had manually triggered the reset. Within the science teams, quiet tension spread. ESA had always prided itself on radical transparency data from missions like Rosetta or Mars. Express had been open to the public within days of capture. Yet 3I Atlas seemed to follow a different protocol. Even senior analysts could no longer access the unfiltered images. A few hours later, an internal memo appeared on the network. Temporary restriction, pending data integrity verification. The note didn't explain what needed verifying, but those who had seen the raw frames already knew what might be at stake. The missing thermal sequence contained the first confirmed instance of negative heat radiation, the moment when 3I Atlas had cooled itself in full sunlight. Releasing that data without explanation could ignite speculation far beyond what the agency was prepared to handle. Inside ESA's European Space Operations Center in Darmstadt, the revision team worked through the night. They compared readings from the Trace Gas Orbiter, Mars Express, and James Webb. The numbers aligned too precisely to dismiss as error. The comet had not malfunctioned, the instruments hadn't either. Something real had happened, and it was still happening. At 6:17 UTC, the agency's internal dashboard changed color, a quiet sign among staff that a classification shift had occurred. 3I Atlas was no longer listed under Comet Observation Program. Its new label read Interagency Object Review. The tag meant its data now passed through a cross-check system shared between ESA, NASA, and JAXA, a process normally reserved for high-impact or politically sensitive findings. Publicly, nothing was said. The official social media feeds continued posting generic updates, star maps, Mars photos, a countdown to the next launch. But behind closed doors, access logs showed something extraordinary. A handful of user credentials belonging to only 3 analysts were authorized to open the full 3 iAtlas dataset. Everyone else was locked out. In the following days, the version of the data that returned to the public archive looked slightly different. The images were smoother, their light curves rounded off. The noise filters set unusually high. Subtle details had been softened. The cold plumes now appeared diffuse instead of structured. Independent astronomers who compared the new files to earlier screenshots noticed faint geometric differences in the gas halo, as if layers had been digitally flattened. ESA issued a brief statement the next day. Preliminary data from the ExoMars Trace Gas Orbiter has been adjusted to correct for processing anomalies. No physical irregularities were detected in the target body. It was the kind of statement written not to inform, but to quiet. Yet among those who had seen the original data, the wording stood out. No physical irregularities detected didn't mean none existed. It meant none had been declared. Privately, several astronomers sent encrypted messages to colleagues abroad, confirming what the public would not see. The deleted thermal frames showed the gases of 3 iAtlas cooling far below the temperature of the surrounding space. The emission pattern was sharp, layered, not random, not natural. A week later, a whistleblower from within ESA's Data Integrity Unit leaked an excerpt of the internal review log. One line, in particular, spread rapidly through underground research forums. Spectral reconstruction indicates organized emission consistent with guided venting. Recommend restriction until correlation is confirmed. Guided venting. 2 words that no one had ever associated with a comet. By the end of that month, the agency had still not reinstated the missing datasets. Requests for comment went unanswered, and internal investigators began tracking IP addresses accessing archived 3 iAtlas material without clearance. Officially, the revision was about calibration. Unofficially, it was about control. The data had crossed a threshold, not of discovery, but of comfort. What 3 iAtlas had shown could no longer be filtered through ordinary science. It needed rewriting, reframing, repackaging into something the world would accept. And so ESA did what scientific institutions rarely admit to doing. They silenced their own signal. They didn't deny the truth. They just slowed it down one revision at a time. The first signs of the anomaly appeared in the spectral maps from the Very Large Telescope in Chile. The readings showed faint metallic signatures in the coma of 3 iAtlas thin emission lines that looked almost like traces of vaporized nickel. But the temperature was far too low for any metal to sublimate. At minus 180 degrees Celsius, nickel should remain solid, inert, locked deep inside the nucleus. Yet here it was, drifting freely through space as a vapor. At first, the analysts suspected a data contamination error. Cosmic rays, stray starlight, or even calibration noise from Mars Express could easily distort readings. But when they cross-checked with the ExoMars Trace Gas Orbiter and the James Webb Space Telescope, both instruments confirmed it. 3. iAtlas was releasing nickel into space. That alone was remarkable. But what came next rewrote the conversation. Where there is nickel, there is always iron. The two are cosmological twins, formed together in the cores of dying stars and fused in the same nuclear reactions. Every asteroid, meteor and comet ever studied contains them in predictable ratios, usually about 1 atom of nickel for every 20 of iron. It's one of the most consistent patterns in the universe. Except this time, the iron was gone. Spectral scans showed absolutely no trace of iron in the gases around 3 iAtlas. None. Not hidden, not faint absent. The atomic lines that should have glowed at 372 and 520 nanometers were flat. The scientists rechecked every instrument. Calibration lasers, thermal corrections, solar interference, all came back clean. The nickel lines, meanwhile, were perfect. Narrow, bright, and pure. For days, the research teams tried to find a natural explanation. Perhaps 3 iAtlas came from a star system with different elemental ratios, or maybe the iron had oxidized into non-luminous compounds. But that theory collapsed when deeper analysis revealed that the nickel wasn't bound to oxygen or carbon. It existed in gaseous metallic form, atomically pure. Then came the second shock. Trapped within the nickel vapor was an inert gas signature. Argon. But not ordinary argon. The isotopic ratio was wrong. On Earth and Mars, argon follows a predictable pattern, mostly argon 40, with traces of argon 36 and negative 38. Yet the argon in 3I Atlas was inverted. Heavy isotopes dominated. Such ratios can only occur under immense pressure, the kind found in planetary cores or engineered fusion chambers. In other words, this gas looked manufactured. A physicist from Kyoto University ran the numbers again using data from Webb's NIRSPEC instrument. The concentration of nickel to argon formed a near-perfect harmonic ratio of 3:5, repeated across multiple observation sessions. Nature rarely builds such symmetry. Random geological processes don't repeat in whole number patterns. That kind of precision suggests a stabilizing mechanism. Perhaps electromagnetic, perhaps artificial. At ESA headquarters, a quiet debate began. If the nickel was being released in perfect intervals and bonded with argon, could it be part of a controlled venting process? On Earth, nickel is used in superalloys and superconductors. When combined with inert gases, it becomes stable under extreme temperature swings, ideal for structural or magnetic applications. Could 3I Atlas be shedding material from some deeper, engineered lattice? The official stance was cautious. The agency called the discovery a rare elemental imbalance. But behind the scenes, the term used in private memos was more direct. Selective release. It implied choice, or at least design. Further modelling only deepened the mystery. When the gases interacted with sunlight, the argon acted like a reflective buffer, scattering energy evenly while keeping the nickel vapor intact. The cloud didn't dissipate. It stayed cohesive, dense, cold, and luminous. It behaved more like an electromagnetic shield than a cometary tail. By mid-November, independent observatories in Chile, Japan, and New Mexico had all confirmed the same pattern. Nickel without iron, stabilized by heavy argon. NASA's Jet Propulsion Laboratory quietly reclassified the object's chemical behavior from volatile to regulated. One internal note, later leaked to the press, contained a single chilling sentence: nickel release consistent with controlled alloy decay. Argon function remains unknown. Controlled alloy decay, a phrase never before used in cometary science. What if 3I Atlas wasn't just leaking? What if it was purging? Because somewhere in that silent blue glow, between the nickel vapors and the argon shell, lies a question no one at ESA wants to ask aloud. Is this chemistry or maintenance? It began as a subtle line buried in the data, an oxygen emission, faint but steady, repeating at perfect intervals. Normally, oxygen in a comet's coma appears in chaotic bursts as sunlight strikes frozen water, splitting molecules into random clouds of hydrogen and O2. It's messy, unpredictable, noisy. But the oxygen leaking from 3I Atlas was none of those things. It was rhythmic, almost mechanical. The first detection came from the Hubble Space Telescope. Its ultraviolet spectrometer picked up a stable oxygen wavelength at 130.4 nanometers, pulsing every 27 minutes. The frequency was identical to the blue gas emissions previously observed, but this new pattern extended across a much broader region of the coma. When plotted on a timescale, the oxygen levels rose and fell like the trace of a heartbeat, not erratic, not fading, but metronomic. At first, the data analysts thought it was an echo from Earth's own upper atmosphere contaminating the readings. Hubble's low Earth orbit sometimes reflects faint oxygen signals through the telescope's field, but when the same rhythm appeared in data from the James Webb Space Telescope, orbiting nearly 1.5 million kilometers away, the explanation collapsed. The oxygen pulse was real, and it was coming from deep within the object. Under normal conditions, oxygen release on a comet comes from sublimation, solar heat vaporizing buried ices. But by this point, 3I Atlas had already proven it wasn't behaving like a normal comet. Its temperature had fallen, not risen. It was releasing gases without heat. That made this oxygen anomaly even more perplexing. Cold oxygen emissions imply one of two things: either chemical recombination within the gas itself, or a process capable of producing molecular oxygen without sunlight. The ESA spectroscopy division in Darmstadt began running simulations. Using standard comet models, they found no combination of pressure or temperature that could sustain this kind of regular oxygen release. Even exotic models involving electrostatic discharge or microfractures failed. The gas wasn't venting at random, it was venting on schedule. A scientist from the Mars Express project noticed something else. The oxygen signal matched the object's magnetic rotation period to the millisecond. Every time the magnetic field completed a full cycle, the oxygen emission peaked. The two signals were locked together, as if controlled by a single mechanism. That discovery changed everything. If magnetism was driving the release, then 3I Atlas wasn't simply melting or breaking apart. It was interacting with its own magnetic field, using it to control gas output. This is something seen in fusion containment devices, not in celestial bodies. To verify the link, the ESA requested parallel readings from the Bepi-Colombo probe, then passing near the inner solar system. For a brief 2-hour window, it aligned with the same solar longitude as 3I Atlas. The probe's magnetometer detected synchronized pulses not of radiation, but of oxygen ions. They were traveling along invisible lines of force, forming thin corridors of plasma that extended thousands of kilometers outward before vanishing into solar wind. In effect, 3I Atlas was breathing drawing in particles, holding them, then exhaling them in magnetic rhythm. When the data reached the Joint Planetary Data Center in Madrid, one physicist wrote a single sentence in her internal memo: "The gas is not venting, it is being modulated." That line spread through the community in whispers. Modulation implies control. Control implies energy. And energy, in this context, implies technology, or at least a natural process that mimics it perfectly. NASA's oxygen mapping algorithms were rerun 3 times to rule out processing errors. Each iteration returned the same result: perfectly symmetrical peaks, recurring at 1,620 seconds apart. The discovery sparked a quiet divide between agencies. The European side favoured a natural explanation. Perhaps the oxygen was trapped within crystalline ice that fractures periodically under internal stress. The American teams were less certain. They noted that the gas's photon scattering profile was too clean. Instead of diffusing outward like vapour, the oxygen lines remained sharply bounded, as if confined by an electromagnetic barrier. By late November, the phrase oxygen containment pattern appeared in an internal ESA report. It was never made public, but one of the reviewers later described it anonymously to a journalist. It's as if the gas knows when to leave. Some proposed that 3I Atlas contains reactive materials, nickel, argon, and oxygen that feed into each other, cycling energy between phases to maintain equilibrium. Others saw something more deliberate, a system managing itself, preserving structure as it travels through space. Whatever the cause, the data shows one clear truth: the oxygen within 3I Atlas behaves with purpose. It pulses when no heat exists, aligns with a magnetic field that shouldn't exist, and refuses to dissipate like ordinary cometary gas. In the end, one quiet conclusion made it into the final draft of the internal analysis. The source of the oxygen emissions remains unknown. The rhythmic stability suggests an organized release mechanism not accounted for by current models of cometary physics. He not to build in full 146. Organized. That single word changed the tone of every discussion thereafter. Because nature can be chaotic, but organization, especially in a comet that glows blue, exhales in rhythm, and hides behind its own magnetic veil, suggests something far stranger, something alive, or at least aware. When the first high-resolution particle trajectories from 3I Atlas came in, no one believed them. The models showed thousands of microscopic dust grains moving inward toward the nucleus, against every physical law governing comets. Outgassing should push material away, not draw it back. Yet, for reasons no algorithm could explain, the debris cloud of 3I Atlas behaved like a reversed fountain. The anomaly was discovered by a data team working on the ExoMars Trace Gas Orbiter. Their imaging spectrometer, tuned to track ionized carbon and silicate dust, registered faint arcs that didn't spread outward from the comet's surface. Instead, they curved backward, looping in perfect spirals and vanishing into the coma's core. At first, it was dismissed as a software mirroring error, but when the same pattern appeared in NASA's Mars Reconnaissance Orbiter dataset, and again from Japan's Hisaki Ultraviolet Telescope, the conclusion was unavoidable. The particles were moving the wrong way. Under normal conditions, Solar heat drives sublimation. The released gases propel dust outward at speeds of hundreds of meters per second, forming the long, diffuse tails we recognize from Earth. But 3I Atlas wasn't following that script. Its dust wasn't escaping. It was orbiting. Each fragment seemed to follow a curved trajectory, like an object caught in a magnetic trap. ESA scientists modeled the flow using magnetohydrodynamic simulations. The results were eerie. The particles formed spirals consistent with Lorentz force confinement, the same principle used in laboratory plasma rings. This meant one thing: an electromagnetic field was guiding the dust. That shouldn't be possible for a natural comet, especially one traveling at interstellar speeds. Further analysis revealed that the inward-moving particles weren't just random debris, they carried charge. The instrument readings detected alternating signals of positive and negative ions, alternating every 11 minutes, in sync with the comet's broader magnetic cycle. The particles weren't being drawn back by gravity. They were responding to polarity changes. Each time the field reversed, the direction of motion inverted, sending the smallest grains spiraling back toward the core. One astrophysicist described the effect as a breathing cycle. The comet inhaled, then exhaled, over and over, in perfect rhythm. But nothing that size should be able to generate the field strength necessary to perform such an act. The only known process capable of similar behavior on Earth is magnetic confinement in controlled fusion chambers, machines that hold superheated plasma in looping magnetic fields. A senior analyst at ESA compared the magnetic map of 3I Atlas to that of Earth's auroras. The resemblance was uncanny. Identical curvature, identical phase lag. The difference was scale. On Earth, auroral patterns are fed by the planet's molten core. In 3I Atlas, there's no molten anything, no internal dynamo, no rotating metal sphere. Yet somehow, it was producing the same pattern in vacuum. The next surprise came from the James Webb Space Telescope. Webb's imaging spectrometer tracked reflected sunlight off the dust particles, mapping their vector motion in 3 dimensions. Instead of dispersing into space, the reflective grains formed coherent ring-shaped paths around the nucleus, before vanishing inward. Their speeds were strangely consistent, averaging 62 meters per second, precise to within 1 decimal place. Random dust never moves that uniformly. When ESA cross-referenced these values with previous scans, a disturbing possibility emerged. The incoming dust was not the same material being ejected. The ratios of silicon and carbon were different. The comet appeared to be releasing one type of matter, then absorbing another. The team called this selective intake, a polite term for behavior that looked engineered. On November 19th, a joint paper draft circulated between ESA and NASA, proposing a cautious interpretation. The inward motion might result from static reabsorption, where fine grains cling to an ionized magnetic surface. But in private, several authors rejected the idea. The synchronization was too perfect. One section of the draft later removed read, "This system maintains dust motion in stable feedback loops, as if the nucleus actively collects material from its own environment." By late November, high-speed imaging confirmed the loops visually. Amateur astronomers using stacked exposures captured faint helixes twisting toward the comet's core, glowing faint green where the dust met ionized gas. It was no longer theoretical. 3I Atlas was pulling matter inward, while moving through space at more than 100,000 kilometers per hour. In one internal ESA transcript, a mission planner summarized the discovery bluntly. "The object appears to clean itself." That sentence caused a pause in nearly every department that read it. If true, it meant 3I Atlas could manage its own structure, removing unwanted debris, recycling its outer layers, or maintaining equilibrium as it travels. The public never heard that phrasing. In official releases, ESA called it a magnetic dust interaction anomaly. But among scientists, the language changed. They no longer called it a comet. They began using another word, system, because when particles start moving backward, when a frozen body begins to regulate what enters and exits its shell, it stops being a rock. It becomes something closer to a mechanism. And for 3I Atlas, that mechanism is still running calmly, precisely, and entirely against the direction nature intended. When the first images of 3I Atlas's coma were color-corrected, scientists expected the usual emerald haze, the classic green glow of ionized carbon that gives comets their ghostly beauty. Instead, the data revealed something deeply wrong. Mixed within the green was a layer of faint shifting red, not the dusty orange red of iron oxide, or the warm reflection of Martian light, but a deep, glass-like crimson, pulsing as if alive. The anomaly appeared during a coordinated observation window involving the James Webb Space Telescope, ESA's ExoMars Trace Gas Orbiter, and ground telescopes in Chile and Hawaii. At 3:11 UTC, Webb's infrared camera registered a narrow-band reflection centered at 680 nanometers, right on the edge of the visible spectrum. But unlike ordinary red scattering, this signal intensified as 3I Atlas moved away from the sunday. The farther it drifted from solar radiation, the brighter the red became. The pattern defied every physical expectation. Cometary surfaces brighten under sunlight and dim when shielded. 3I Atlas was doing the opposite, glowing from within, as though illuminated by an internal source. When the spectral data were normalized, a faint harmonic curve emerged. Every 11 hours, the red wavelength pulsed gently, rising and falling in sync with the comet's previously recorded magnetic rhythm. At first, researchers believed it was fluorescent sunlight interacting with exotic molecules in the coma. Yet the reflection curve didn't match any known organic compound. The resonance peaks were too clean, with spacing ratios identical to those found in thin film interference, the optical phenomenon used in engineered coatings and plasma mirrors to control light. That detail changed everything. Thin film interference requires uniform layering at the microscopic level, with reflective surfaces stacked at precise distances apart. Random ice and dust can't create such order. But the spectral interference pattern of 3I ATLAS was consistent with something layered, perhaps alternating sheets of solid and vaporized metals. When ESA's materials division analyzed the data, they found repeating reflective intervals of 176 nanometers, an impossibly perfect spacing for a naturally formed surface. The red glow itself was most intense near the base of the magnetic veil, where the earlier nickel-argon gases were known to collect. There, light didn't scatter. It ricocheted. The reflected photons bent at shallow angles, forming halos that radiated outward in concentric circles. Some scientists began calling it the red shell, though others privately used another term, mirror skin. As the object rotated, the red zones shifted position, always facing away from the sun, as though intentionally redirecting light. Observers from the Very Large Telescope in Chile noted that solar photons striking those areas didn't reflect diffusely. They bounced with extraordinary precision, like beams off polished metal. The result was an effect unseen in cometary science: selective reflection. Only specific wavelengths escaped. The rest were absorbed. One researcher compared it to a photonic diode, a surface that allows light to pass one way but not the other. In engineering, such materials are used to regulate energy flow and protect delicate systems from overheating. In 3I Atlas, the red reflection seemed to serve the same purpose. It appeared precisely where the comet's temperature had dropped during its cold emission phase, suggesting that the glow wasn't decorative, it was functional. NASA's Jet Propulsion Laboratory performed angular reflectivity analysis using polarized light modeling. The outcomes stunned them. The red zones exhibited polarization values consistent with directional scattering. That means the light was being manipulated, guided along vectors that reduced radiation pressure. Effectively, 3I Atlas was steering sunlight. When these results reached ESA's interagency board, the official statement was careful. Observed reflection phenomena may indicate anisotropic surface properties, but privately, the conversation was different. Several engineers admitted that the pattern was too controlled to be random. One scientist asked quietly during a closed meeting, "How many natural objects protect themselves from the sun by engineering their own mirrors?" Over the next few days, attempts were made to reproduce the reflection curve in laboratory conditions. Using metallic aerosols, researchers managed to approximate the glow, but only with nanometer-scale control and polarized laser light. The implication was chilling. What the comet emitted required precision beyond natural deposition. Meanwhile, amateur astronomers on Earth began to notice something unusual through long-exposure imaging. The red tint around 3I Atlas wasn't uniform. It formed a thin crescent on one side, always the side facing away from the sun, always in the same orientation relative to its motion. Some believed it was a tail, others thought it was a shield. By late November, the red reflection had become a defining feature of the object. NASA's infrared logs described it as a photonic layer of unknown origin, highly reflective, non-chaotic in structure. That language, non-chaotic, marked a turning point, because in astronomy, chaos is normal. Dust, gas, plasma, they all behave unpredictably, but the red reflection of 3I Atlas did not. It obeyed an invisible geometry, regulating energy with precision, turning sunlight into silence. And so, the color that should have meant heat instead became a warning, the quiet red of control. The proof that something in deep space knows how to manage light itself. The most startling discoveries about 3I Atlas did not come from distant telescopes or deep space observatories. They came from the orbiters circling Mars. For a few brief hours in early October, the planet became a front-row seat to one of the strangest cosmic events ever recorded. At 4 UTC, the European Space Agency's Trace Gas Orbiter began its scheduled observation run. Its mission was straightforward: monitor the thin Martian atmosphere for methane, hydrogen, and water vapor. But as it adjusted its sensors toward 3I Atlas, the instruments began detecting patterns no one had expected: rising levels of trace gases that had no terrestrial or Martian origin. Methane, oxygen, and even traces of xenon appeared out of nowhere, drifting through Mars's upper atmosphere. Within minutes, the values doubled, then abruptly stopped. At the same time, NASA's Mars Reconnaissance Orbiter, MRO, picked up a subtle anomaly. The planet's ionosphere shimmered. It wasn't a glitch or solar interference. It was as if an invisible wave had passed over the entire hemisphere. The frequency and timing of the disturbance matched the trajectory of 3I Atlas as it grazed Mars's orbital plane. The data alignment was uncanny. Both orbiters, operating independently on opposite sides of the planet, recorded identical energy spikes separated by a mere 47 seconds. That level of synchronization had never been seen between unlinked spacecraft. The conclusion was unavoidable: both were reacting to the same external event. The official explanation at first was mundane: solar wind variation. The sun's charged particles often cause fluctuations in the Martian magnetic field. But this time, solar activity was silent. There were no flares, no coronal mass ejections, nothing. The space weather data from NASA's Parker Solar Probe confirmed the solar environment was calm. When the data from the Chinese Tianwen-1 orbiter arrived, it made the situation even stranger. Its radar spectrometer, scanning Mars's exosphere, recorded a sudden, dense ionized cloud moving against the solar wind, heading toward Mars, not away from it. Within that cloud was a faint spectral fingerprint, identical to the blue gas emissions previously identified from 3I Atlas. It was as if the comet had exhaled directly toward the planet. ESA scientists attempted to triangulate the source of the particles. Using vector analysis from all three orbiters, they traced the gas stream back to the region of space just behind 3I Atlas's coma. The alignment was near perfect. Something had left the object and swept across Mars like a magnetic tide. For 47 minutes, Mars's upper atmosphere glowed faintly in ultraviolet, a whisper of energy that satellites could see but human eyes could not. The trace gases lingered briefly, then diffused. But they didn't behave like typical cometary debris. Instead of dissipating randomly, they moved in smooth, parallel lines, clean, organized, silent. When the ExoMars mission team overlaid the timing of the event with internal logs, they found something chilling. The communication blackout that affected multiple space agencies earlier that week occurred during the exact same window. Every probe pointing toward 3I Atlas lost partial telemetry not for hours, but for the same precise duration, down to the millisecond. It wasn't just signal loss. It was silence. In post-event analysis, ESA's plasma physicists noticed that the ionized gases over Mars carried an electrical bias. The polarity was reversed, meaning they didn't match the charge of the solar wind. They weren't repelled by the sun. They were attracted to it, as if guided by a countercurrent. Reversed ions, one engineer called them. Particles that move the wrong way. Mars Express's magnetometer later detected faint ripples, waves of magnetic compression rolling through the thin Martian magnetotail. These ripples matched the frequency of the gases emitted by 3I Atlas, creating a resonance that should have been impossible between two separate celestial bodies. When the data was compiled, one sentence in ESA's internal briefing stood out: Interaction between 3I Atlas and the Martian atmosphere produced coordinated ion fluxes, inconsistent with passive cometary behavior. That was the agency's way of saying, it didn't just pass by, it affected Mars. NASA scientists proposed a cautious interpretation. Perhaps the comet's gases carried electromagnetic properties strong enough to induce temporary plasma coupling. But others saw something deeper. The gases appeared targeted, directed precisely along the planet's orbital path, arriving with mathematical precision. Some even speculated that Mars had been chosen that 3I Atlas, through whatever process drives it, released energy intentionally while crossing the planet's orbit. The official reports ended politely. Further observations are required, but the unspoken truth remained. For the first time in history, multiple orbiters witnessed a comet not merely reflecting sunlight, but interacting actively, shaping another world's atmosphere, changing its fields, then vanishing without a trace. The universe had shown a new kind of relationship, not collision, not chaos, but synchronization, and for those 47 minutes, Mars seemed to listen. In space, pressure doesn't behave the way it does on Earth. There are no winds, no weather systems, no air currents, just vacuum, radiation, and plasma flows guided by gravity and magnetism. Which is why, when scientists at the European Southern Observatory first plotted the pressure distribution around 3I Atlas, what they found made no sense at all. Instead of the usual gradient high pressure near the nucleus, low pressure fading outward, the data revealed concentric rings. Each ring was separated by equal intervals of density, expanding and contracting in perfect rhythm, like ripples on the surface of invisible water. And those ripples repeated every 11 hours, the same cycle as the object's magnetic field and oxygen pulse. At first, no one believed the map. The pressure values were too uniform, too deliberate. Instruments measuring such subtle variations normally show chaotic noise, yet these readings were smooth, structured, and symmetrical. The data came from multiple instruments: the ExoMars Trace Gas Orbiter, Mars Express, and the James Webb Space Telescope, each operating independently. When all three returned the same pattern, the coincidence became impossible to ignore. The discovery started as a calibration test. Engineers at ESA were mapping plasma density in the solar wind as 3I Atlas passed through the Martian sector. But instead of finding a turbulent trail, they detected layered compression zones, extending more than 100,000 kilometers from the comet's center. The gas wasn't dispersing randomly, it was being organized by pressure waves. One researcher compared the pattern to an acoustic resonance chamber, a place where sound creates standing waves. Except, she wrote in her internal note, there's no medium for sound. The pressure waves aren't sonic, they're magnetic. ESA's plasma dynamics team ran magnetohydrodynamic, MHD, simulations to test the idea. The results were astonishing. When the comet's magnetic field was modeled as a rotating torus, the gas density oscillated in lockstep, forming the exact same rings seen in the data. The field appeared to breathe, compressing and releasing gas in regular intervals. Normally, comets emit jets of vapor that fluctuate randomly depending on sunlight and surface structure. But 3I Atlas's emissions behaved like coordinated pulses. The densest zones formed near the magnetic equator, then radiated outward, fading and reforming in cycles. The pattern looked like a heartbeat, slow, steady, and impossible. To confirm the phenomenon, the team turned to the Mars Express spacecraft. Its onboard radar altimeter, usually used for terrain mapping, was repurposed to measure electron density in the plasma wake trailing behind 3I Atlas. What it found deepened the mystery. The wake wasn't turbulent, it was structured. Instead of chaos, the data revealed corridors of alternating high and low plasma density. Magnetic corridors, the report called them. The structure wasn't static either. Every cycle, the rings shifted slightly inward, as though pressure waves were being drawn back toward the core. It looked less like outgassing, and more like a controlled pulse compression and retraction, a rhythm that repeated for days. NASA's Deep Space Network recorded complementary anomalies. Signals bouncing off the comet's surrounding plasma returned with faint phase distortions, echoes repeating at consistent intervals, matching the same 11-hour rhythm. When converted into sound, the data produced a low-frequency hum, a tone that rose and fell in perfect regularity. Engineers nicknamed it the breathing signal. By the second week of analysis, The word pressure no longer captured what they were observing. The phenomenon behaved more like modulation, as if 3I Atlas were manipulating its surrounding gases intentionally to maintain equilibrium. Each time the sun's radiation increased, the rings contracted, tightening into dense shells that deflected solar wind. When radiation decreased, the shells expanded again, releasing the built-up pressure. It was a stabilizing system, one that protected the comet from solar and magnetic stress. ESA's report summarized the finding in cautious language. Observed plasma pressure oscillations appear to demonstrate a self-regulating feedback process, maintaining equilibrium, independent of external solar flux. In other words, 3I Atlas could regulate its own environment. For many on the research teams, that conclusion was quietly disturbing. Objects don't self-regulate. They react, they erode, they disintegrate, they don't adjust. Yet the maps showed otherwise. The pressure rings weren't an accident of motion or sunlight. They were part of a process. An internal NASA email, later leaked to journalists, captured the growing unease. If the pattern persists, it implies closed-loop behavior. The system isn't passive, it's adaptive. Even the skeptics couldn't ignore the evidence. Nature can create symmetry, but not precision across multiple independent instruments, and certainly not synchronized across 11-hour intervals. By late November, the term pressure map had evolved into something else among those who studied it closely. They called it the pulse field, because 3I Atlas didn't just move through space, it breathed. It balanced, and it maintained a rhythm no comet should ever have. And somewhere inside that rhythm, between compression and release, scientists began to wonder whether they were still studying a comet or watching a living mechanism at work. When the James Webb Space Telescope pointed toward 3I Atlas for its scheduled observation, the goal was simple: to capture mid-infrared data of the gases escaping the interstellar comet's surface. But within hours of the first analysis, technicians at the Space Telescope Science Institute realized they had recorded something that shouldn't exist. A signal had appeared deep within a restricted portion of Webb's sensor array, a wavelength band scientists usually filter out because it overlaps with the telescope's own thermal emissions. This was the forbidden wavelength. Webb's mid-infrared instrument, MIRI, was designed to block out radiation near 3.6 microns. That range is usually contaminated by the telescope's own heat and background noise from the sunday. But on October 24th, at precisely 4:19 UTC, the system logged a structured pulse of energy exactly in that blind spot, bright, coherent, and repeating. The data team ran a full hardware diagnostic. Every system checked out. The signal was not an error. It was coming from 3I Atlas. At first, the amplitude looked random, small spikes buried in noise, but when the raw data was Fourier transformed to search for patterns, a rhythm emerged. The spikes were not random at all. They formed intervals of 1.6, 1.8, the golden ratio, the same proportion previously found in the comet's blue light emissions. It was a mathematical signature, the cosmic equivalent of a fingerprint. The 3.6 micron wavelength corresponds to low-energy molecular vibration, the kind produced by carbon-oxygen bonds or ionized dust. But these pulses didn't behave like molecular vibrations. They behaved like modulation-controlled signals embedded in the thermal noise. The pattern repeated precisely every 1,620 seconds, exactly matching the rhythm of the comet's oxygen emissions and magnetic cycles. Inside Webb's control center, the team had to make a decision. Either flag the data as corrupted and ignore it, or accept that something truly unknown was emitting structured light at a wavelength their own instruments were never meant to detect. They chose to study it. When the brightness curve was plotted over time, it showed a strange symmetry rising and falling in two mirrored halves, like an equation folding onto itself. The peaks carried small sidebands, faint echoes that appeared slightly delayed, as if the main signal had bounced through layers before reaching the telescope. To test that theory, the scientists modeled the delay patterns using ray tracing simulations. The results suggested that the light was passing through a lattice, a repeating internal structure capable of bending infrared radiation without scattering it. In other words, 3I Atlas wasn't just emitting light, it was processing it. ESA's spectroscopy division later overlaid Webb's data with readings from the ExoMars orbiter. The alignment was shocking. During each pulse of the forbidden wavelength, the Mars probe recorded a simultaneous drop in charged particle density near the comet's magnetic veil. When the wavelength peaked, the field weakened. When it dimmed, the field strengthened. It was as though the emission itself was driving the comet's magnetic balance like a stabilizing heartbeat. By the second week of observation, the pattern had repeated 43 times. The phase difference between consecutive peaks never changed by more than 1/100th of a second. That level of precision does not exist in nature. Stars flicker. Planets wobble. Comets tumble. Nothing in the sky maintains that kind of consistency, unless it's being controlled. Webb's engineers began calling it the metronome. The forbidden wavelength wasn't constant light. It was timing a regulating pulse, and each time it appeared, the surrounding gases of 3I Atlas briefly reorganized, compressing into tighter shells before expanding again. One astrophysicist from the European Space Operations Centre wrote in her confidential log, "We are observing feedback behavior emission linked to environmental correction. This is no passive body." NASA's official public summary used safer language. Unidentified mid-infrared variability detected near instrument noise threshold. Further study required. But the unredacted internal report contained one additional line that never made it to press. Signal exhibits logarithmic amplitude modulation, consistent with low-frequency communication encoding. Communication, the word hung, like static across every department that read it. Was the comet transmitting? Was it simply reacting in ways that mimicked information flow? Or had humanity just intercepted a form of physics it couldn't yet classify? The data continues to be debated, reprocessed, and sometimes quietly dismissed. But one fact remains indisputable. In the middle of the telescope's blind zone, a region designed never to register cosmic light, 3I Atlas spoke. It used warmth where none should exist. It used precision no random object could achieve. And somewhere, within that forbidden wavelength, between silence and static, the universe whispered in mathematics, a rhythm repeating from an object that may not be silent at all. The phrase came from a single engineer's late-night note, 2 words written in the margin of a spectral log. Frozen lightning. It sounded poetic, almost careless, until other researchers began to see the same thing in the data. On October 26th, the Kyoto Astrophysics Laboratory attempted to reproduce one of 3I Atlas's emission patterns using controlled plasma experiments. They wanted to know why the comet's gases were producing blue and green light at temperatures far too low for ionization. The experiment was straightforward. Expose xenon and argon gases to varying voltages in a cryogenic chamber and observe the spectral output. What they saw, after several trials, made the room go silent. At number 220 degrees Celsius, when high-voltage pulses were introduced, the gas began to glow not randomly, but with the same spectral fingerprint that had been observed coming from 3I Atlas. It should have been impossible. Plasma, the fourth state of matter, where atoms lose their electrons, can't exist at such low temperatures. It needs heat, yet the experiment showed it could exist if the electrical field was strong enough and perfectly contained. And that was exactly what the comet seemed to be doing on its own, hundreds of millions of kilometers from any known energy source. The Kyoto team published a preliminary report titled Electroluminescent Discharge in Cryogenic Gas Environments. In its final line, they wrote, "Spectral correlation with observed Comet 3I Atlas emissions is greater than 97%. Mechanism unknown." That phrase, mechanism unknown, spread quickly through the international research network. If 3I Atlas was producing electricity in the vacuum of space, it was violating everything astrophysics assumes about non-rotating, non-metallic bodies. Back at ESA, magnetometer data from the Mars Express orbiter offered a possible clue. During each cycle of the comet's blue light pulse, the orbiter registered microbursts of static electricity short, repeating discharges that aligned perfectly with the changes in magnetic polarity around the comet. The bursts looked like miniature lightning strikes, except they weren't accompanied by heat or radiation. They were silent, frozen, electrical events. Theorists began exploring how such behavior could occur naturally. One idea suggested that 3I Atlas contained metallic hydrogen, a material that acts as a superconductor at low temperatures. If the comet's core was laced with conductive elements like nickel or cobalt, as earlier data hinted, then solar particles could trigger current loops that persist indefinitely. The surrounding magnetic field might trap these charges, causing the gases to ionize without heat. A self-sustaining cold plasma system. But the geometry of the emissions didn't match random discharge. The lightning wasn't diffused or branching. It followed precise channels, linear filaments that wrapped around the nucleus in uniform arcs. The pattern resembled the magnetic field lines of a tokamak reactor, the same technology used on Earth to contain fusion plasma. In essence, 3I Atlas looked like a natural, stable fusion vessel, one operating at near absolute zero. NASA's Goddard Space Flight Center performed computer modeling to test this. When they simulated electrical discharge through a magnetic torus surrounded by cryogenic gas, the results matched almost perfectly. The gases condensed into solid filaments, conducting electricity like frozen wires. Under high magnification, these filaments would appear as threads of light, exactly what Webb and Hubble had both seen shimmering within the comet's halo. To the naked eye, it would look like veins of lightning trapped in ice. The implication was profound. Frozen plasma is theoretically stable enough to store energy over astronomical timescales. If that was true, then 3I Atlas wasn't just glowing, it was conserving power, charging and discharging as it moved through the solar wind. ESA's final internal note on the matter avoided the word electrical. Instead, it referred to localized energy retention phenomena. But an unredacted draft leaked to researchers in Japan contained the real description. Observed discharges resemble electrostatic confinement and recombination events consistent with controlled plasma behavior. Controlled plasma behavior. The phrase brought a chill to even the most skeptical scientists, because nothing about 3I Atlas was supposed to be controlled. It was supposed to be frozen rock and dust, an ancient relic drifting through the void. Yet the deeper the data went, the more it looked like an engineered system, one that could harness electrical charge, maintain its own field, and release energy in precise, repeatable bursts. When the Kyoto experiment concluded, the lead researcher was asked what he thought 3I Atlas really was. He paused for a long moment and said quietly, "If lightning can freeze, then energy can sleep." And somewhere beyond Mars, the sleeping energy of 3I Atlas continued to glow lightning that refused to fade, frozen in motion and pulsing with a rhythm no storm could ever produce. It began quietly, a gap in the data logs so small that only a few researchers noticed it. On November 3rd, at 2:11 UTC, the European Space Agency's open access science portal briefly went offline. When it came back, dozens of files related to 3I Atlas were missing. The disappearance wasn't random. Every dataset containing raw spectral data from October 22nd through October 29th, the period covering the oxygen anomaly, magnetic veil expansion, and the frozen lightning observations, had been deleted or replaced with placeholders labelled revision pending. For public users, this looked like routine maintenance, but those who had previously downloaded the data noticed something strange. The replacement files were smaller, compressed differently, and stripped of their metadata. Timestamps were gone. Cross-references to instrument calibration logs were removed. When ESA's official archive moderators were asked for clarification, they gave a familiar line: "The files are undergoing calibration review." But the calibration had already been verified weeks earlier. Nothing about this was routine. The first real alarm came from the astrophysics community itself. Independent researchers in Chile and Japan, who had been working on correlating 3I Atlas's magnetic data with thermal readings, discovered that their citation links were now broken. The ESA server redirected all external traffic to a general Mars mission directory. It wasn't an error, it was a deliberate rerouting. Soon after, 2 internal employees at the European Space Operations Centre confirmed that an internal memo had been circulated, temporary reclassification of volatile datasets due to ongoing validation. That phrasing was bureaucratic, but the intent was clear. The data was being locked down. The missing files weren't just random science logs. They included high-resolution imagery from Mars Express, particle analysis reports from the Trace Gas Orbiter, and telemetry from the ExoMars communications relay, the same relay that had gone silent for 47 minutes during 3I Atlas's close pass near Mars. Those images, in their uncompressed form, had shown faint geometric structures within the comet's coma density bands, arcs, and pressure layers that appeared too regular to be natural. Researchers who had saved early versions described grid-like light distributions and magnetic symmetry that matched laboratory plasma confinement fields. Then, without warning, those same images disappeared from the ESA archive. NASA's planetary data system mirrored the same behavior shortly after. Requests for access to the original FITS files, the unprocessed raw data, were met with polite rejections. Data temporarily restricted, pending cross-agency verification, the automated message said. That phrase, cross-agency verification, is typically used when data involves classified defense satellites or planetary protection protocols. But 3I Atlas was neither. By mid-November, speculation spread through the astronomy community. Some believed the agencies had detected a composition so unusual it risked public panic. Others suspected data corruption. But the more seasoned researchers had a different theory. The agencies had found patterns they couldn't explain and couldn't risk misinterpreting in public. An internal ESA leak later confirmed those suspicions. A short document titled DGR Lock 4 surfaced anonymously on a restricted forum for astrophysicists. It contained a single paragraph from an internal review log. Spectral reconstruction indicates repeating amplitude modulations and interference patterns incompatible with stochastic natural emission. Recommend restricted handling until further characterization. In loss of the Snownick, in plain language, the deleted data showed a repeating pattern, a signal embedded in the comet's light. When journalists reached out for comment, ESA issued a short, carefully worded statement. Some 3I Atlas data files were removed for technical consistency checks. These files will be restored upon completion of verification. But weeks passed. Nothing returned. The placeholder files remained. Behind the scenes, researchers began sharing screenshots and mirror copies of the early datasets. The archived images clearly showed emission frequencies forming symmetrical arcs, with spacing so precise it could only be described mathematically 1.618 intervals, the same golden ratio modulation observed earlier in the forbidden wavelength data. It was a code written in light, and for the first time, the agencies were not just observing a natural phenomenon, they were curating it, deciding what the world could and couldn't see. By December, the deletion expanded. Search queries for 3I Atlas on NASA's Open Archive redirected to blank pages. Even internal crosslinks inside ESA's network produced error messages marked Access Tier 3, Administrative Hold. Only classified programs use Tier 3. For the public, 3I Atlas had simply gone quiet. But among scientists, a different understanding took hold, that silence was being engineered. Not because the data was broken, but because it spoke, and until someone could explain what it was saying, it would remain locked away, hidden behind the calm language of calibration, verification, and review, while the truth itself shimmered unseen in the deleted light of 3I Atlas. It began as a faint shimmer, an emerald outline that appeared just beyond the comet's visible coma. At first, astronomers thought it was a reflection artifact caused by solar glare or scattered particles from Mars's atmosphere. But as 3I Atlas continued its slow arc beyond the orbit of Mars, that faint glow grew wider, denser, and far too organized to dismiss as a trick of light. By early November, telescopes across Earth, Mars orbit, and the L2 observation point all recorded the same anomaly, a perfectly circular halo of green light surrounding 3I Atlas, expanding outward at a steady rate of 2,300 kilometers per hour. The halo didn't diffuse like a gas cloud, it held shape, a luminous shell that seemed to pulse with internal structure. The first to measure it precisely was the Mars Express orbiter. Its sensors detected a layer of ionized oxygen and nickel interacting with the magnetic veil already observed around the comet. But what startled the team most was the temperature. The halo wasn't hot. In fact, it was colder than the surrounding vacuum, measuring nearly 3 degrees below the predicted baseline. In space, cooling like that requires energy. Massive amounts of it, yet 3I Atlas wasn't losing heat. It was generating cold. ESA's plasma dynamics team mapped the halo over 5 observation windows. Each time, the structure reappeared with the same boundaries and thickness, like a living shell rebuilding itself. Inside the halo, the comet's green emissions pulsed in slow waves that followed a Fibonacci progression, the same mathematical rhythm already observed in the forbidden wavelength, detected by the James Webb Space Telescope. To test if the phenomenon was purely visual, The team cross-checked the optical data with ultraviolet readings. The halo existed across multiple frequencies. It wasn't just light, it was plasma, magnetized and synchronized. A field. Then came the most unexpected discovery. The halo rotated. It didn't spin with the comet's body, but counter-rotated at a slightly slower pace, completing a full revolution every 19 hours. This meant one of two things. Either the halo was being stabilized by the comet's magnetic field, or it was being driven by something else entirely. An ESA report labeled it electromagnetic halo propagation, type unknown. The language was cautious, but the internal memos were not. Several scientists described the event as a self-sustaining field envelope, a term usually reserved for energy containment systems. When the James Webb Telescope captured new infrared frames, the images revealed the halo's texture in stunning detail. It wasn't smooth. The plasma had arranged itself into spirals, looping filaments of luminous gas arranged like fingerprints, each arc separated by equal distance. The ratio between these spirals was identical to the harmonic spacing found in acoustic resonance systems on Earth. The comet wasn't releasing gas randomly, it was tuning it. NASA's Goddard Center ran modeling simulations to see if this could be a natural phenomenon. They input every known parameter: mass, magnetic field strength, solar radiation pressure. The result was unequivocal. The pattern was too precise. Natural diffusion cannot produce concentric halos with stable internal resonance. The system required feedback, something adjusting the flow from within the nucleus itself. Meanwhile, observers on Earth began to notice a new visual signature. Through long-exposure imaging, the comet appeared to have two luminous layers, an inner blue-green core and an outer ring of faint golden light. The green glow dominated, but the golden edge traced the boundaries where solar radiation and the halo interacted. It was as if the comet had built a shield, an electromagnetic atmosphere distinct from its physical body. ESA scientists nicknamed it the breathing sphere. Every time the halo contracted, spectral emissions spiked. Every time it expanded, particle density dropped. The cycle was consistent 10.5 hours long, the same frequency as the comet's earlier magnetic oscillations. The entire object, field and core together, was pulsing in perfect rhythm. By mid-November, the halo's diameter had exceeded 400,000 kilometers larger than the Moon's orbit around Earth, and yet, through every expansion, it held perfect geometry. No turbulence, no collapse. The pattern was eerily calm. An internal ESA summary, never released to the public, described it this way: the plasma halo surrounding 3I Atlas displays harmonic field coherence and dynamic stability, inconsistent with any known unregulated process. The emission behavior suggests containment, not decay. Containment. The word lingered in every private discussion. If the halo was containment, what was being contained? Some speculated it was the byproduct of energy storage, the same mechanism responsible for the frozen lightning events observed weeks earlier. Others suspected it might be a defensive field, absorbing radiation and dispersing it harmlessly through oscillation. No one could say for sure, but one fact was undeniable. The green halo wasn't just expanding, it was alive in its behavior, balancing light, magnetism, and motion in ways no comet ever should. By the time ESA closed its final observation session of the year, one researcher wrote a simple line in her private notes: the halo is no longer following physics, it's following pattern. And pattern, in the universe, is never random. It's intention written in light. By the time 3I Atlas cleared Mars's orbit and began drifting into the deeper solar wind, one question hung over every agency tracking it: where did it come from? The question wasn't new, but the evidence now made it urgent. Its gases were unnatural, its magnetism organized, its temperature inverted. The comet didn't behave like an object formed in chaos. It behaved like something built with memory. Tracing its path backward should have been straightforward. With modern orbital modeling, astronomers can reconstruct an object's journey across millions of years. But when the Jet Propulsion Laboratory attempted this for 3I Atlas, the simulation broke down. Every time they ran the trajectory farther than a few thousand years into the past, the data diverged into noise. Small gravitational perturbations, the kind normally smoothed by probability models, amplified wildly, as though the object had no coherent history. One researcher described the effect as Cosmic camouflage. Its past could not be reconstructed. Every attempt to locate its entry point into the solar system ended in a void, an empty vector pointing toward interstellar space. Then, in late November, an independent team at the Harvard-Smithsonian Center for Astrophysics tried a different approach. Instead of mapping backward from its current position, they mapped forward from known star systems, simulating what interstellar debris could plausibly reach our system within the last million years. Out of hundreds of trajectories, only one matched. A narrow corridor extending from the Sagittarius arm of the Milky Way, the same region that produced the famous 1977 "wow" radio signal. The alignment was so precise it startled the entire review board. If 3I Atlas truly originated near Sagittarius, its journey would have taken millions of years, crossing dense molecular clouds, gravitational eddies, and high radiation zones. Yet somehow, it had arrived intact, unscarred, unchanged, perfectly stable. That shouldn't be possible. In the chaos of the galaxy, comets erode, fragment, or spin off course. A body this symmetrical would have required constant correction, as if it were steering itself. At ESA's mission control in Darmstadt, analysts noticed something else. When they reconstructed the earliest known position of 3I Atlas, its trajectory crossed the orbital plane of the first interstellar visitor ever detected, 1I, Oumuamua, albeit separated by years. The angle difference between their entries was exactly 49 degrees, the same number that had appeared repeatedly in the early 3I. Atlas data, the tilt of its approach, the shift in its oxygen pulse, the cycle of its pressure waves. Coincidence or signature? No one could decide. The internal discussions turned speculative. Was 3I Atlas part of a larger family, a sequence of objects seeded intentionally through interstellar space? Some proposed that these bodies were natural messengers, fragments of the same primordial cluster. Others wondered if they might be artifacts, remnants of ancient technology, adrift between stars. NASA's SETI division quietly ran a deep spectrum analysis for non-random modulation across the comet's emissions. The report that followed was never released, but a leaked excerpt summarized it in one haunting line. Detected frequency harmonics are non-chaotic and self-referential across multiple emissions. Statistical likelihood of random origin is less than 0.0004%. That number, less than 1 in 25,000, implied purpose. Meanwhile, James Webb's extended survey revealed another clue. Hidden in the ultraviolet range were faint, linear scars across the comet's surface, parallel grooves that ran in perfect alignment with its magnetic poles. Their spacing was uniform to within 2 millimeters, far too precise for geological stress fractures. The grooves looked machined. Publicly, scientists avoided that word. They used safer ones: striations, symmetry features, erosion artifacts. But in private, the language shifted. The question was no longer what 3I Atlas was made of, but who made it. By December, some within ESA began calling it a constructed remnant, not a ship, not an active probe, but a vessel of data, a fragment of something that once carried meaning. And so the theories divided into two camps. One saw 3I Atlas as the product of natural evolution, a mineral intelligence born from physics itself, forming systems that resemble design only because order always emerges from chaos. The other saw it as deliberate, a silent transmission traveling through eons, still obeying commands encoded in light. Either way, its origin story now stretched beyond the solar system, beyond the timeline of humanity, perhaps even beyond biology itself. Because no matter which version you believe, the evidence converges on one truth. 3I Atlas did not come here by accident. It arrived on schedule. The first time silence appeared in the 3I Atlas data, no one paid attention. Telemetry gaps happen all the time. Radio interference, solar static, buffer overloads. But as the comet drifted farther from Mars, the gaps began to return with unnerving precision. Every 11 hours and 12 minutes, communications from multiple satellites monitoring 3I Atlas would cut out for exactly 41 seconds. Then, without error or drift, they would resume as if nothing had happened. It was NASA's Deep Space Network that first flagged it. Analysts in Canberra noticed that the loss occurred across separate spacecraft: the Mars Reconnaissance Orbiter, ExoMars Trace Gas Orbiter, and even Bepi Colombo, millions of kilometers away. These platforms use different frequencies, different protocols, and even different agencies, yet their connection to the comet dropped in perfect sync, separated by milliseconds. Initially, the engineers suspected a fault in time synchronization, a server misalignment in the deep space network, but when ESA confirmed that its independent tracking center in Darmstadt had recorded the same outages, all suspicion of error vanished. The silence wasn't a malfunction. It was coordinated. What made the pattern so alarming was its mathematical precision. Each gap began and ended at predictable intervals, aligning with 3I Atlas's magnetic cycle and oxygen pulse. When analysts mapped the timing onto the comet's rotation, they found a match. The 41-second silence always occurred when one specific region of the object faced the Sunday. The implication was staggering. It meant the silence was positional. Webb's infrared sensors soon confirmed a subtle dimming in that same window, a slight drop in thermal emissions across all wavelengths. Not enough to indicate power loss or shadowing, but enough to suggest deliberate regulation. For those 41 seconds, the comet seemed to turn itself off. Scientists called it periodic blackout, but the data told a deeper story. During the silences, surrounding magnetic turbulence stabilized completely. The oscillations flattened. The entire region around 3I Atlas became perfectly still, as though every particle had frozen in place. Then, at the 42nd second, motion resumed. The effect baffled plasma physicists. There's no known process that could induce total field quiet across multiple frequencies without active suppression. In nature, even the emptiest vacuum hums with residual noise. 3I Atlas had somehow erased that hum briefly, rhythmically, and predictably. Some likened it to a cosmic heartbeat contraction and release. Others whispered about something more unsettling. Transmission. The silence itself might be the message. Hidden within those 41 seconds, the instruments occasionally detected faint subharmonic frequencies, residual echoes that lingered for less than a millisecond after the blackout ended. When converted into visual data, these echoes formed a geometric waveform, a sequence of equilateral triangles stacked vertically. The pattern repeated across multiple observation cycles. ESA's internal analysis described it diplomatically. Observed interruptions show coherence across independent datasets. The correlation suggests non-random suppression behavior. Non-random suppression, a phrase that instantly captured the imagination of every scientist on the project. Suppression implies intent. Attempts to reproduce the phenomenon in laboratory plasma chambers failed completely. The magnetic silence of 3I Atlas could not be recreated by natural or artificial fields without external modulation. The comet was behaving as if it were performing maintenance, a self-check, a moment of controlled stillness, before resuming activity. After 3 weeks of continuous monitoring, the silences evolved. What began as 41 seconds extended to 44. The intervals stretched imperceptibly with each rotation, as though the pattern itself were adapting. NASA's official statement, released quietly to the press, read, "Transient data loss has been recorded during solar alignment phases of Object 3I Atlas. Investigation ongoing." But the unedited internal version said something else. Loss of signal repeats across agencies with uniform precision. Behavior consistent with deliberate modulation or signal masking. He wilted to the DUSA. Deliberate. Masking. Words that no one wanted to say publicly. Some theorists proposed that the silence might act as a shielding event, a mechanism to protect the comet's internal systems from solar interference. Others saw a more unnerving possibility. The blackout was an output, a burst of non-radio data, transmitted in a form we couldn't decode. By December, the pattern remained unbroken. Every 11 hours, 12 minutes, 44 seconds silence. A pause in radiation, in motion, in every measurable force. It was as if 3I Atlas had its own sleep cycle, and in that silence, in that impossible perfect stillness, the universe itself seemed to listen back, because sometimes what isn't said carries more meaning than anything that is. And for 41 seconds at a time, 3I Atlas said nothing yet told us everything. It began as a trace reading a faint line in the lower end of the ultraviolet spectrum that didn't match any known element or molecular compound. At first, the analysts assumed it was a calibration error from the ExoMars Trace Gas Orbiter's spectrometer. But when the same signal appeared simultaneously in data from the James Webb Space Telescope and ESA's Mars Express probe, the error theory died instantly. The wavelength was sharp, consistent, and utterly alien. Its emission line sat at 232.08 nanometers, a range where no known atomic transitions occur under normal temperature or pressure. More confusing still, the gas responsible for it seemed stable, self-contained, and replicating in the outer halo of 3I Atlas. For the first few days, ESA's chemistry division called it unidentified molecular band 232, but the nickname that stuck among the staff was simpler: the impossible gas. To understand why, you need to understand cometary chemistry. Every comet observed so far follows a basic rule. As it approaches the sun, heat turns frozen compounds, carbon monoxide, ammonia, water, into vapor. Those vapors form a coma, the glowing cloud we see from Earth. But 3I Atlas wasn't warming up, it was cooling down. And the mysterious gas wasn't forming through sublimation, it was forming in the cold. Its spectral properties defied explanation. The gas absorbed ultraviolet light yet re-emitted it as faint green glow, amplifying certain frequencies rather than scattering them. It behaved like a photonic catalyst, redirecting light rather than reflecting it. When the team ran computer models to estimate its molecular weight, the results contradicted known chemistry. The inferred mass-to-charge ratio didn't match anything on the periodic table. For weeks, analysts thought it might be an exotic isotope, perhaps a metastable form of nitrogen or oxygen. But further analysis revealed it wasn't isotopic at all. Its energy transitions implied a quantum structure that shouldn't hold together under classical physics. Then came the strangest part. It replicated. Repeated observations over 10 days showed that the gas concentration doubled every 36 hours, not by expansion, but by apparent creation. The amount of matter in the region was increasing without any detectable input of energy. No chemical process on record can multiply mass without drawing from an external source. NASA's Goddard team cross-checked against solar wind flux, hoping to find an explanation in charged particle reactions. But the solar wind was calm. The gas was producing itself silently, methodically, and without fuel. A confidential ESA memo described it this way: observed gas displays self-propagating photonic reaction cycles inconsistent with entropy-driven chemistry. In other words, it was anti-entropic gaining order from chaos. Physicists at CERN were asked to review the spectra. Their verdict was cautious but astonishing. The emissions could only be explained by a molecule existing in a supercooled plasma lattice, something capable of holding electromagnetic charge at near-zero energy cost. On Earth, such states are created artificially in particle traps for nanoseconds before decaying. 3I Atlas had been doing it for weeks. The discovery triggered an emergency classification. Public data feeds were suspended for recalibration. In private, the agencies feared something far larger than a cometary mystery. If the gas truly consumed radiation and produced more of itself, it was a perfect energy sink, or worse, a perfect energy storage medium. Some speculated it could be a natural superconductive plasma, a kind of cosmic battery. Others whispered that it might be engineered a byproduct of a system designed to collect energy silently as it travelled through space. When the James Webb Telescope captured its final ultraviolet composite, the data revealed something haunting. The gas wasn't just floating. It was forming hexagonal filament strands that organized into repeating patterns like microscopic circuitry. Their structure matched the harmonic spacing seen in the comet's green halo. A senior researcher at ESA summarized the finding bluntly in his restricted access note. This compound should disintegrate instantly in vacuum. Yet it persists and multiplies. We are observing a state of matter that violates chemical and thermodynamic constraints. Source: unknown. Mechanism: unknown. Purpose: unclear. The phrase "purpose unclear" lingered longer than the data itself, because for the first time, scientists weren't just seeing a strange element. They were seeing a behavior, one that implied continuity, regulation, maybe even function. The gas that shouldn't exist was doing more than existing. It was organizing itself, growing, synchronizing, adapting as though responding to something we couldn't detect. And as 3I Atlas moved deeper into the solar system, That impossible gas trailed behind it like breath in the cold, glowing green in defiance of every rule of matter we thought we understood.